All right, the last example is going to be a word problem, okay? So here's the problem. A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? So the first thing that I want you to do is draw a diagram because it could help us unveil some more truth to this and be a lot more easier to visualize, okay? So let's start off by creating that flagpole. Well, a flagpole is just going to be a straight line going down. And we don't know how tall this flagpole is. So if we don't know something, we're just going to use the variable x. And then it says that it casts a shadow. So this shadow over here, it casts a shadow that is 40 inches, that is 50 feet long. So I'm going to say 50 feet over here. And it casts a shadow because the sun is shining, right? So I'm going to create this kind of third side over here to represent that. That is a triangle here, okay? So that is the flagpole. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. Oh, same idea over here. Over here, this is our woman. She's skinny. And she is what? 5 feet 4 inches tall. And she is casting a shadow that is 40 inches long. So this is 40 inches. And again, the sun is shining. The tank is clean. And oops, that is not a straight line. And we should have that same triangle, right? So these look pretty similar, right? And these are similar because look, it's perpendicular, first of all, right? It's the ground is horizontal, and then we have people standing up straight. So these are both 90 degrees. Oh, look, it is a pair of congruent angles. And assume that these two angles over here are also congruent because the sun is shining at the same place. So by, I don't know, by logic, these two angles are also going to be congruent. So now that we have proven that these two angles in two separate triangles are congruent by the AA similarity, triangle similarity theorem, these two triangles are now similar. Oh, so if these two triangles are similar, we know that they should have the same scale factor and they should be proportional from one triangle to another. One side is going to be proportional to the other side of a triangle, okay? So the first thing that we want to notice also is a little bit more about the detail. We notice that these are all in different measurements, right? Units of measurement. We have feet and we have inches. And what do we know about feet and inches? Well, 1 foot is the same thing as 12 inches. To make the solving easier, let's go ahead and make and convert all of these measurements into inches, okay? So 5 feet 4 inches. Well, if we have 5 feet, that means it's going to be 5 times 12, which is 60 inches. And then we have an extra 4 feet, so 60 plus 4 equals 64 inches. So instead of, instead of me putting 5 feet 4 inches, I'm just going to replace it with 64 inches. 64 inches. And what about this 50 feet over here? Well, I don't want feet, I want inches. And 1 foot is the same thing as 12 inches. And so 50 feet times 12 is going to give us 600. So instead of writing 50 feet, now we have 600 inches. And notice now everything's in inches, okay? Very cool. Now that we know that these two triangles are similar to each other, let's go ahead and set up a proportion to find out the value of x. So again, set up a proportion. We have to compare corresponding sides. So let's start off with this 640. From one side to another, we'll set it up like this. 600 over 40 has to be the same scale factor, the same proportion as what? X, compare it to 64. So it has to be the same as x over 64. Has to be the same fraction, has to be the same scale factor. So how can we prove that? To find out the value of x, Let's cross multiply, okay? So if we cross multiply, 40 times x is going to give us 40x, and that's going to equal 600 times 64. 600 times 64 is 38,400. And then what are we going to do to both sides of the equation to isolate for the variable x? We're going to divide both sides by 40. So 40 over 40 is just x, 1x, equals 38,400 divided by 40 is 960. 960 what? Inches. But what is the question asking us? How tall is the flagpole to the nearest foot? Now we just have to convert it back from inches to feet. How do we do that? Let's divide 960 by 12. So x is going to equal 80 feet. And let's see if it's the same scale factor just to check our work, okay? So if x is 80, 80 over 64 is going to give us what? 80 over 64, 80 divided by 64 is 1.25. Whoops. And what about 600 over 40? It has to be the same scale factor. So now 600 divided by 40 is 50. Wait. No. I lied. It has to be, wait, no, that was feet. So it has to be, my bad. 960 over 64. So 960 over 64 is 15. And then 600 over 40 is also 15. So it's the same, okay? So we have just proven the height of the flagpole. Okay, that's it. Bye.